Welcome to Max and Mins. All right, so here's the question. The sum of two positive numbers is 56. Find the two numbers if their product is to be the maximum. So here's the first part of that question. The sum of two numbers is 56. So we can interpret that as x plus y equals 56. And I've got x plus y graphed in Desmos here, and you can see that I changed the ends to gray because it said that the sum of the two positive numbers. So we're keeping x positive and y positive, and that gives us the line that is there in the red. Okay, so we know what the line looks like. X plus y equals 56. So any combination of that x and y will equal 56. Okay, now we want to figure out what the x times y, the second part, is the product of those two numbers at those different points, and we're wanting to find what the maximum number will be when we have an x times y, but those two numbers also add up to equal 56. So here is a graphical representation of what's going on when we've got two numbers that add up to 56 but multiplied together. So we can see at the bottom of the graph we've got 0 plus 56 equals 56, but 0 times 56 equals 0, and then that's an x and a y coordinate. And on the other side, we've got an x coordinate of 56 and a y of 0. So those two add up to 56, but multiply together to be 0. And you can see I've just graphed some points along the x-axis to show how they add together to equal 56, but what they multiply together. And you can see if you've got 5 and 51, then we've got 10 and 46, and we can see that it's basically like a parabola shape, and that at the tippy top it looks like 28 times 28 ends up being our max, and that is equal to 784. So that was a lot of work graphically plotting that curve. The other thing that was nice about this problem is it came out to a nice round number, 28 times 28 at the top. And if that number wasn't round, it would be more difficult to figure out what that max is. So the question is, can we now figure out this max using calculus? And we're going to start with our two original formulas. We've got x plus y equals 56. And we've got an x times y is going to be our max. So if we get everything in terms of max, right, we've got max is equal to x times y. Now if we take our original formula and solve for an x, we get x equals 56 minus y, right? That was our x plus y equals 56. So that second formula under the calculus thing, bullet point, x equals 56 minus y, that's just that first formula in terms of x. So now if we substitute into the max formula, max is equal to x times y, the x equals 56 minus y, we substitute that in for the x, we can now solve for a max in terms of y. So we get max is equal to 56y minus y squared. And now we can do the exact same thing for the x, and we get a max value is equal to 56x minus x squared. All right, so now we've got two formulas in terms of max y and max x. Now, if we observe on our graph here of the curve, we notice that at the very peak, at the max, our slope is equal to 0. So we have no slope at that very peak, right? And if we remember back to derivatives, the derivative is the instantaneous slope of the curve. And so now if we take the derivative of our original formulas, we get d max over dy equals 56 minus 2y, and d max dx is equal to 56 minus 2x. Now, knowing at the slope is going to be 0 at the max, we can substitute in the value of 0 for our d max dy, d max dx, and then solve for a y that's going to be equivalent to the max. And when we do that, we get a y max is equal to 28. And we do the same thing for the x, and the x max is equal to 28. So now we know, using calculus and derivatives and setting the slope equal to 0, we know that when x plus y equals 56, our maximum value of those two numbers multiplied to each other are going to be represented by an x equals 28 and a y equals 28. So our maximum is equal to 28 times 28, equaling 784 when the same x and same y are added together, equaling 56.